Welcome to today's homework help video. We are on page 147, and this is asking us to state without actually solving how many solutions there's going to be, whether they're going to be real or non-real. So we only have three options. First option is two real solutions. Second option is one real solution. And third option is no real solutions, which means that there's two non-real solutions. Almost always those are going to end up being complex, but the book says non-real because it is possible for it to just be imaginary, not necessarily complex. So this one, or rather for all of these, we're going to be using the discriminant, not the determinant, as I was saying in the notes. It is the discriminant, and the discriminant formula is just what's inside of the square root of the quadratic formula. So b squared minus 4ac. And basically, if it's positive, we have two real. If it's 0, it's one real. And if it's negative, it's two non-real. And there you go, that's it. So we have A and B and C labeled here. Pause it and try for yourself with this formula. All right, so we have b squared minus 4ac, 4 times a times c. So I can already tell that this is going to be two real solutions because a negative and a negative make a positive. So I'm going to have 16 plus a number. I don't even care what that number is. All I care is that it's positive. In the interest of being a completionist, I'll go ahead and do a few calculations at least. Positive, I already said that. 4 times 16 is 64. 64 times 13 is a very large number. That's 640. Let's see, can I get this? 640 plus 3 times 64. It's a big old number, yeah. So this is going to be some large positive number. So we have 16 plus some other big old number. That's going to be a positive. It's some positive number. And that's really all I care about. It doesn't actually matter what the number is, except for being positive, 0, or negative. That's the only thing we care about. So just based off that, this is two real solutions. Number 10, try it for yourself. And let's label. We have A and B and C. B squared is going to be negative 11 squared. Be very careful if you're doing some calculator work and you say negative 11 squared and you do not put parentheses, it will tell you it's negative 121. It's not. Don't believe it. Anything squared is positive. Well, any real number squared is positive. And you're given all real numbers in this stuff. So let's go ahead and finish plugging in. We have minus 4 times A times C. Okay, 121 minus 4 times 7 is 28. That's 280. So this is a negative number. Negative 159, is it? I want to say 159, but it doesn't particularly matter what the number is. The only thing that matters is that it's negative. So this is two non-real solutions. Again, almost certainly it's two complex solutions, but just to be sure, we'll just say non-real instead of complex, just in case it's just imaginary, not a complex number. Okay, number 11. This one is not set up properly. It's not set up for the quadratic formula. Hey, I have a bird biting my ear. Sorry about that. Okay, so this is now set up properly. I'm going to show you a trick. This does not seem like it's going to be very fun to work with. We're going to have to square that, right? That's b, and we're going to have to square it. So what if we got rid of this fraction somehow? What if we multiplied everything by 5. I don't know why I put a fraction symbol if I'm going to multiply everything by 5. Let's get rid of that. That's stupid. So if I multiply this by 5, and this by 5, and this by 5, and this by 5, well, it should work, right? Everything, you're doing a legal operation. You're multiplying everything left and right of the equal sign by 5. And so this actually will not change the answers. And it certainly won't change the type of answers. So this is actually something you can do. This is just manipulating functions. So this is completely legal. Let's see what we get. Okay, that looks a lot better to work with. So is that cheating? No, I don't think so. I think it's perfectly reasonable. Another thing you could do is multiply everything by negative 1, or again, from this very first step, you could have multiplied by negative 5. That would have gotten rid of all the negatives, only positives to work with. But, you know, that time has passed. We'll just work with the negatives. Negatives aren't that bad to work with. Fractions are very annoying to work with. So that's a little trick you can do. Always be on the lookout for a way you can manipulate an equation to make it a little bit easier to work with. Okay, so we have A and B and C. B squared is going to be negative 2 squared minus 4AC, 4 times A times C. Okay, it looks like to me like we are going to have a negative discriminant, because 2 squared, that's only 4. And this is a number that's certainly much larger than 4. A negative times a negative times a negative is a negative. So we got 4, we're taking away more than 4. In fact, we're taking away 100, I do believe. So this is negative 96. 2 non-real solutions. Easy. All right, next. Again, it doesn't look how it's supposed to look, so try number 12. This is the first step I am going to do. Subtract 12x from both sides, make it look the way it's supposed to look, and there we go. A, B, and C, and it's looking to me like right off the bat, once you start getting fairly good at this stuff, you'll kind of get an intuition. Of course, now that I say this, I'll probably get it wrong, but 12 squared is rather large. I'm kind of feeling like it might be a positive number here, but we'll see. Minus 4AC. Okay. And you know what? I think we're going to get 0 here. This is going to be 144. 4 times 4 is 16. 16 times 9, that's 90 plus 54. There you go. It's 144. So it is, in fact, 0. And just like I said, I called it. I was wrong. So it's not going to be a positive number. It is, in fact, going to be 0, which means there's one real solution. And there you go. That's those first 4. Let's move on to the next page, where we're actually going to be working with the actual quadratic formula. On to page 149. These are the problems we have. Solve the equation using the quadratic formula. Not too bad. However, the thing that's going to ruin your day. Check a solution by substitution. So we have to do the quadratic formula, no problem. But then we have to take one of the, well, most of these problems, in fact, I believe all of these problems have 2 solutions. We're going to have to take one of those solutions, plug it back into the original equation, and see, do we actually get 0? Does it work for the original equation? Okay, that's going to be an awful lot, but I'm not going to ask you to do anything that I won't do myself, so let's get started on it. Okay, we have A, B, and C. So A is 1. If you don't see a coefficient, it is 1. B is negative 8. C is 27. And let's plug in. We get x equals negative of negative 8. I'll even write that for the first one. For future ones, if b is negative, then you just put positive of whatever that number is. Inside our square root, that's where our discriminant goes. So this is going to be negative 8 squared minus 4ac. So that's what I got for plugging in. Don't forget the denominator of the quadratic formula, 2a. Okay, cool. Let's start simplifying. It's going to be a slog. Let's just get through it. Negative of negative 8 is 8. 8 squared is 64. 4 times 1 is 4. 4 times 27 is 108. Okay, this was a lot longer than it needed to be. And 2 times 1 is 2. Cool. We can do some more simplifying. 64 minus 108 is negative 44. Yeah, that's right. We have the square root of a negative. We're going to remove the negative from the square root and put I outside of the square root, outside of the radical. Furthermore, 44 is 4 times 11, so we can call this 2 root 11, because, the square root of 4 is 2. And it's going to be 2 root 11i because of that negative. We can do a little bit more simplification, and we probably should, since we have to plug back in. So we should make this as simple an answer as we can before we have to plug in and do all the calculations there. So 8 divided by 2 is 4. 2 root 11i divided by 2 is just root 11i. The 2's cancel. And that is our simplified answer. So we're going to have to take either the positive or the negative version. We're going to have to plug it back in for x. After all, we're saying that x equals one of these two. That's our two solutions. Well, we got to put our money where our mouth is and prove it. So we're going to take, let's go ahead and use the positive version. Plug it back in here and see if we do in fact get 0. So let's give it a shot. So x squared, we're saying that this is x, so we're going to say 4 plus root 11i squared, but wait, there's more, minus 8 times 4 plus root 11i plus 27. And this should equal 0. All right, let's see if that's true. This I'm going to do by the box method off to the side, just to save myself a little bit of space. Okay, 4 and root 11i. 4 and root 11i. 4 times 4 is 16. Root 11i times 4 is, well, 4 root 11i. Oh gosh, I have to write so small here. Sorry if it's difficult to read. Same thing over here. 4 root 11i. If you need to see it, get a microphone. What? A microscope? That's what I wanted to say. Root 11 times root 11 is just 11. I times I is negative 1, so this will be negative 11. Cool. Okay, so we've simplified this into this stuff. We have 16 minus 11 is 5. 4 root 11i plus 4 root 11i is 8 root 11i. And that is the simplification. This stuff has become that stuff. The rest, just write it out. Although I will distribute this negative 8. So we have minus 32 minus 8 root 11I plus 27. Believe it or not, we're almost done. I have positive 8 root 11I and negative 8 root 11I. Cancel, cancel. That's good. Now I only have real numbers to work with. 5 plus 27 is 32. Negative 32 plus 32 is 0. So yeah, this does in fact equal 0. And it's difficult to believe all this junk, and if you plug it into something like that, you do in fact get 0. Kind of cool. Let's give it a shot with number 18. Okay, once again, A is 1. I need all the space I can get. I'm going to put A, B, and C on the top this time. B is negative 30. C is 50. I forgot to say pause and try it for yourself. So, hey, I've identified A, B, and C for you. Pause and try it for yourself. Let's get started. X equals 30 plus or minus. Again, last time I'm going to note this. Since this is negative, negative of negative 30 is positive 30. 30 squared. Technically it's negative 30 squared, but that's the same as positive 30 squared, so I'm going to be lazy. Minus 4 AC. Well, the nice thing is this one is not going to be complex. It will be real, but it might still have a square root. In fact, it probably will. So that doesn't mean it's going to be any easier. And then 2a here. Okay, next step. 30 squared is 900. Yes, that's right. I'm good at math. 900. 4 times 50 is 200. And like I suspected, we're going to have the square root of 700. That's not a perfect square, so we will have a square root to deal with. How unfortunate. Next step, we have 30 plus or minus root 700 over 2. 700, that's just 7 times 100. So this one is a perfect square, so we'll go ahead and use that combination. So the square root of 100 is 10. This is going to be 10 root 7. At least there's no I, but yeah, it's still pretty messy. One more time, we can do some simplifications with the division. 30 divided by 2 is 15. 10 divided by 2 is 5. And we're told that these are the solutions: 15 plus 5 root 7 and 15 minus 5 root 7. Just for fun, we chose the positive last time. Let's choose the negative this time, just to change it up a bit, you know? Variety is the spice of life. So let's plug in. X squared minus 30 times that 5 root 7 plus 50, and we're seeing, do we get 0 just like it told us we should get? All right. Even though this is not an imaginary part, complex number, I am still going to use the box method to multiply this out. It's personal preference. You can absolutely use FOIL, but I just like the box method. 15 minus 5 root 7, and 15 minus 5 root 7 again. 15 times 15 is 225. Pays to have your perfect squares memorized. 15 times 5 is 75, so this is negative 75 root 7, as is this. 5 times 5 is 25. Root 7 times root 7 is 7. So this is going to be 25 times 7. And that is, oh gosh, isn't that also 225? It is, right? Or am I going crazy? 175, not even close. 175. Yeah, that's right. 25 times 7 is 175. And again, that's 5 times root 7 times root 7, 175. So, well, it will be very obvious very soon if I got my math wrong, because then it won't add up to 0. So let's go ahead and add these together. This gives me what, 400? 400, yeah. And I have negative 150 root 7. I said root 5 here. That's supposed to say root 7. My bad. Minus 150 root 7 minus, okay, 30 times 15 is 450. And this is going to be minus 450. Negative 30 times negative 5 is positive 150 root 7, which leads me to believe that I did my math correctly. I have negative 150 root 7 and positive 150 root 7. I have 450 and negative 450, so it does equal 0. All this complicated stuff just to get 0. You gotta love it. Moving along. Look at number 19. At least the numbers are small. Okay, no problem, but they're not set up correctly. So let's go ahead and move x squared to the other side. We're going to subtract x squared from both sides and get negative x squared plus x plus 3 equals 0. So we have an a value of negative 1, a b value of positive 1, and a c value of 3. So pause and try it if you have not already. Let's start filling it in. I'm worried that we don't have enough space for this one. I'll try to write smaller. Okay, so negative 1, that's negative b, plus or minus square root of b squared minus 4ac all over 2a. All right, I think I got that. Let's start chipping away at it. We have 1 squared is 1. Well, I'll start writing before I haven't even got there yet. 1 squared is 1. Negative times a negative is a positive, so this is going to be plus 12. And they couldn't have been nice to us. They couldn't have given us a perfect square. Oops, see what I was doing? I was thinking ahead. I was thinking 12 plus 1 is 13, and I wrote 13. At this point, however, it's still only 12. So be careful. That's a really common mistake, at least for me. I assume for everybody else. And 2 times negative 1 is negative 2. Cool. Let's keep going. Yeah, let's keep going. Nah, I'm going to say that a negative and a negative, you can cancel that. And look what happens here. It's kind of nice. We have a plus and minus. So we can actually cancel the negative with the plus or minus sign. The plus becomes a minus, the minus becomes a plus, and it makes no difference whatsoever. So if you didn't catch that, remember this is 2 answers. This is negative 1 minus this stuff, in which case the negatives can cancel. The negatives cancel here, and the negative will cancel with a minus and change it to a plus. But I already have a plus one, and it's also negative 1 plus this stuff. The negative can cancel with the negative, and the plus will change into a minus, basically distributing that negative. So what happens is I can cancel these pluses, and because it's plus or minus, it really doesn't change anything with the square root, with the radical, because the negative changes into a plus, a positive, and the positive changes into a negative, so it makes no difference. So we get a little bit lucky there. We don't have to worry about the negatives. Okay, so I have 1 plus root 13 and 1 minus root 13 all over 2. So this one's going to be a little unpleasant in its own special way because it has a fraction that we're going to plug into our equation. So let's go ahead and do that. We have negative of this stuff squared. I'll go back to the positive version. Where are we? Plus that. Plus 3, and we should get 0. Okay, no problem. Let's square this stuff. We get negative. Let's box method that stuff wherever I have space to do so. One and root 13. 1 and root 13. Okay, that's 1. This is 13. This is root 13, and this is root 13. So it looks like I end up with 14 and 2 root 13. Yeah? I hope you guys see that. There's root 13 and root 13. That makes 2 root 13, and 1 plus 13 is 14. So I have 14 plus 2 root 13 over 4. And then I still have to distribute that negative. By the way, the 4 I got because 2 squared. When you square something, you just square the numerator, you square the denominator. So that's the numerator squared. Here's the denominator squared. Plus, I have a sneaking suspicion that we should probably break this into 2 different fractions, and we'll do the same thing to this one as well. I think it's just going to be easier to see what to cancel and all that stuff. So I'm just going to call this 1/2 plus root 13 over 2 plus 3. And let's do some simplifications at the same time that we're breaking it into 2 fractions. So we can see that 14, that's even. This, that's even. That's even. So I could divide all of these things by 2. So this becomes 2. This becomes 7. And this just drops off and just becomes root 13. Let's also apply our negative. So this is negative 7 minus root 13. And those are both going to be over 2. So negative 7 over 2 and negative root 13 over 2. Now we're having fun. Plus 3. Holy moly, this one is crazy. Let's go ahead and keep going though. So negative 7 over 2 plus 1/2. That's negative 6 over 2, aka 3, or negative 3 rather. So that's these two. Yeah, this one at least is nice. Negative root 13 over 2 and positive root 13 over 2, they cancel. And this gets us negative 3. We also have a plus 3, and we get 0. All right, that one was quite the doozy. And that wasn't even the last one. I'm scared to do the last one, but let's get it over with. This is going to be quite the long homework help video. I apologize about that. Okay, first step is to pause and try it for yourself. Second step, now that you've all already tried it, subtract 4x from both sides. We're going to move it to the other side of the equation. We get 2x squared minus 4x plus 7 equals 0. Set up for the quadratic formula. Let's plug in x equals 4. Here's b, plus or minus square root of b squared minus 4ac. All over 2a. Okay, so I see something promising. This is 4 and that's 4, so hopefully everything will cancel nicely. Based on our previous problems, not likely. But you never know. Sometimes the book is nice to us. Every once in a while. 4 plus or minus square root of 16. 4 times 2 is 8. 8 times 7 is 56. So this is minus 56. So we're going to have an imaginary part, or rather we're going to have a complex number over 4. Keep going. 16 minus 56 is a number. The number is negative 40. So I was really hoping that everything would cancel nice and neat. That's not going to happen though. So this one's going to have an imaginary part. It's also going to have a fraction. So they saved the best for last, it looks like. How unfortunate. We can simplify this a little further. The negative we can take out and call it I. It's negative in the square root, I outside the square root, because again the whole square root of a negative is an imaginary number. So we have 4 plus or minus 40. That's 4 times 10. I think that's the best we can do, isn't it? Yep. So 4 times 10, and the square root of 4 is 2. So this is 2 root 10 I all over 4. Now we can simplify these a little bit. Not a ton, but you know, every bit helps. I would love to say that I can just, cancel these. And technically what I could do is I could say 4 divided by 4 is 1. Yeah, sure, let's do this. It's a little bit different, but you know what? It sometimes helps to see different ways of doing things. 2 divided by 4 is 1/2. And so what I can do is I can call this 1/2 root 10I, or I could write it like this, root 10 over 2I. So those are both legal. I'm going to use this way because, well, I already wrote it, so might as well keep it. Last time, we're going to plug back into the equation 2 times that stuff. Let's go ahead and just stick with the positive. We already did one that was negative. We showed it worked. Let's just stick with the positive. It's probably a little bit easier. Root 10 over 2I squared. What is it net? Minus 4 times that stuff. 1 plus root 10 over 2I plus 7 equals 0. Or rather, we're trying to prove that it does equal 0. So let's begin. I'm not going to have enough space. I'll just go down on the margin on this side. No big deal. Okay, so I cannot distribute until I square it first. That's part of the distributive property. You can only distribute into parentheses that do not have exponents and that only has like addition and subtraction inside. So let's go ahead and box method this part. Oops, you can't see that. Here we go. 1 and root 10 over 2I, and 1 and root 10 over 2I. This one's easy. This corner, root 10 times root 10 is 10. 2 times 2 is 4, so this is 10 over 4. And then I times I is negative 1, so this is negative 10 over 4. Which, I don't know why I wrote it like that. I should have said 5 over 2. In fact, that's bugging me. So I'm going to change this to 5 over 2. Cool. Next. 1 times those things. We like multiplying by 1. They just stay the same. Root 10 over 2I. Cool. So we have 2 copies of this. And that's going to give us 2 root 10 over 2I. And so the 2's are just going to cancel. And we just have root 10I. Okay, so this plus that is just going to be root 10I, because this will give us 2 of this, and then the 2's cancel. All right, so I said basically the same thing twice. Forgive me, I'm getting tired. So we have 1 minus 5 over 2. So this is 2 over 2. If we want to make it easier to combine, we can say this is 2 over 2 minus 5 over 2. That's negative 3 over 2. We have, like we said, root 10i minus, let's go ahead and do this distribution. We have minus 4, and sorry, this is going to be minus. Okay, so 4 times root 10 over 2. This is 4 over 1, and we can cross cancel. The 2 cancels, and we can take 2 out of 4, and we're left with 2 root 10i. And almost done. We need to do this distribution, and some nice things should ideally happen. 2 times 3 over 2. 2's cancel, and you're just left with negative 3. I think I forgot to say negative 3 over 2. It is negative, of course. 2 times root 10i. Well, that's 2 root 10i. Everything else stays the same. And would you believe it? That and that cancel. Negative 3 and negative 4 makes negative 7. Plus 7 is 0. We do get 0. So that one was quite the doozy. But yeah, they all worked out. So that homework was a little ridiculous, but doesn't it feel so nice to have it done? So I hope that homework help video was helpful. And you can clearly see that the algebra was really ramped up in this unit. Not every unit is going to have algebra that's this intense, but it is important to have these every now and then to really practice those skills and push your logical limits. Can you keep track of every little symbol? So that's it for today. Thank you for watching, and I will see you in the next video. Bye-bye.